Almost done. Just need to talk about PCR. So this is actually a polymerase chain reaction. It can copy a lot of DNA without using plasmids. And so it makes tons of copies, and I only need about one cell to start. So I don't need to use bacteria, plasmids, E. coli. I don't need to use any of that. So it's copying DNA in a test tube. Pipettes. What do I need? A template strand of DNA, DNA polymerase, nucleotides, A, T, C, and G, and a primer. The primer is that little piece of DNA that gets everything started. The primers are critical. You need to know a little bit of the sequence to make the proper primer. Luckily, you don't need to do that. Usually you charge it, or you just buy it. And those bracket that target sequence, whatever gene you're looking for. Start with a long piece of DNA and copy the shorter segment. The primers define the section of the DNA that you want to clone. So it goes through 20 to 30 cycles, 3 steps per cycle, 30 seconds per step. And so you have double-stranded DNA. It gets denatured because we heated it up. You cool it down, it anneals, which basically it's going to glue together, and then at more room temperature, it extends. So it adds DNA and keeps doing that. So here you can see station, annealing, and extending. I'm making my DNA. And it'll just keep doing that. So what do you need to do? You take a tube, you put a liquid in. It's a very, 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 very small amount, which includes the DNA, the polymerase enzyme, the primer, and the nucleotides. After that, you stick it in the machine. And the machine is then going to heat it up to separate. It's going to cool it to hybridize the primer and build the DNA, which is extension. What does 90 degrees do? It can start to destroy it. So if you heat the DNA, denatures it, it unwinds it, and it's going to destroy that polymerase. And you're going to have to add new enzyme every cycle. You have about 30 cycles. That doesn't seem practical, so we need someone who can withstand 90 degrees Celsius. And we have found Taq polymerase in the hot springs. Good old bacteria, what would we do without them? And so we found that, and we've now added that in with all our PCR. Thank you, Carrie Mullis. Right, and done.